So I'm going to be talking about a field, or basically something which is emerging as a new field, which is AI in cyber offense. And I'm going to be tying it back into real world scenarios, or pretty much what are the kind of AI related cyber attacks that we are currently seeing, some of which is impacting most of the organizations around Southeast Asia, some of them in different parts of the world. So when you talk about AI, when you talk about cyber, there are basically two things. Number one is the offensive use of AI, and second one is the offensive abuse of AI. I'm not sure about India, but majority of the countries down in Southeast Asia as well as in the US, they have a mandate to roll out AI. You're talking about chatbots being rolled out, you're talking about agentic bots being rolled out. Even my line of work, we do insurance. We have around 60 applications that are on AI rolled out to the public. Now, what that does is it gives multiple venue for attackers to collect information, misuse the information, even trigger it. So that's the offensive abuse of AI. But for today's session, I'm going to be talking about the offensive use of AI. If you are as old as me in cybersecurity, you would recognize the image on the first time, which is the Lockheed Martin cyber kill chain. If you are some of the millennials or the new Gen Zs, you would look at the one on the bottom, which is the Mitra attack map. Essentially, any cyber attack can be broken down into these 7 or 11 stages. It first begins with recon, collecting intelligence information, weaponization, preparing for the attack. Delivery is how you deliver the payload. Exploitation is getting your breakthrough within the organization. Installation is maintaining your access within the organization. Command and control is establishing a callback, a beacon to the mothership or wherever it is. And then you act on objectives. Now, the reason I've actually put this over here, because it has got no AI, is that I'm going to be running through some of the examples for each of these phases. And after my slide, I would normally try and include a real scenario or a real case study. So when you go down to the bottom one, that's the Mitra attack, which is more relevant, which is what most of the organizations are up to now. It's more expanded. It even has got mapping back to your tools, techniques, and procedures. Let me start off with the first one, initial access. Now, traditionally, an attacker who's targeting a particular organization or a company, they will start with either mass phishing, which is sending out infinite amount of phishing emails to different people, different users, different infrastructure members, hoping to get some kind of access into the organization. Now, that would be followed by either credential stealing or malware deployment. The second one, which is now rising up, where we see most of the organizations being compromised, is credential stuffing. There are tons of credentials that are already compromised out there in the dark web. People tend to take that, pass it through a bot, try and validate which one works. So we see a significant spike in credential stuffing happening across. The third one is vulnerability scanning. Now, if you look at most of the attacks that are going in, or the vulnerabilities that are increasing in, they are more on your network segments, your Cisco's, your firewalls, your VPNs, etc. Because they are your external facing devices. Any vulnerability on that gains you access into it. Now, in this traditional format, what happens is campaigns often fail. They require manual retargeting. It is painful and it is hit or miss. So what we do is we use AI. Now, when we bring in AI to initial access or social engineering, you can basically generate your phishing lures using LLMs. Let's say, for example, I'm targeting someone in a Cocoon. I basically get the bot to scrap the internet for everything related to Cocoon, find documents, look at the metadata, find email addresses of people in Cocoon, go to the LinkedIn profile, find the relationships. All of this, which I said, happens within a span of 1 hour. And once that is done, the bot basically has got enough information to craft a specific email to one individual with which he will open that email. It's no longer about customizing an email multiple times. And this is the interesting part. Let's say we send an email, the person doesn't reply. It's a security guy, he's not going to reply it. So what the bot does is, it realizes something is wrong. So it tries alternative communication channels. The information that has been indexed is used for sending a WhatsApp message, video calls, Teams chat, Slack messages. So there are multiple communication channels which it reiterates till the person actually responds. Now, the advantage of this is it's completely autonomous. There is no person sitting behind having to look and do this. Another methodology is, like I said, in the case of vulnerability, normally there is a theory called the internet is dead theory, where 70% of the traffic in the internet are from bots. Now, what that does is it creates noise. Large noise from a single IP source will automatically be picked up by your blue team or your CERT or your defense team. Now, the bots can actually get the meta information, apply specific targeted attack with patience on different time frame to a particular network infrastructure so that it doesn't generate enough noise for the attack to be picked up. Like I said, these sounds theoretical, cinematic, they sound like in the movies, but it's an actual case. A story in Malaysia where a CFO of one of the prominent banks got fired for transferring $250,000 to a scammer. What happened was the CFO got a WhatsApp message from the number of the CEO saying, this is one of our important shareholder, you need to transfer 250,000 Malaysian ringgits. CFO didn't reply. She got an email saying that, I understand you might have assumed that I'm afraid. So from the CEO's email, which is a back, the CFO gets another email. After 30 minutes, she gets a video call from the CEO saying that I am stuck in the airport. Can you please do the transfer now? 3 verification, CFO transfers the money. The whole thing was bogus. The CFO got sacked. And this is a real life case. And what I'm showing you here is something which was published by Okta. It's called V0 from Versalship. This is basically a phishing kit. So what you can do is, let's say you have a screenshot of a website, or you know a domain name, or you have an idea. You just type it in the prompt. It creates a phishing site. It lets you deploy it. Another example. We have seen almost 40% increase within our organization alone from Dracula fish kits. Dracula again is heavily used by the Chinese. So this was the launch of the AI functionality in Dracula. So let's say I want to target a bank like State Bank of India. I can just go to the text prompt, say, I need it to match SBI. These are the inputs. This is where I want it deployed. Fish kit gets built, deployed. So what that allows us to do is, nowadays you don't need individuals triggering multiple chains of attacks. You now have multiple bots who are actually orchestrating it with precision. And if we look at the bot analysis from 2024, there are at least 74.5% of all phishing emails are polymorphic, which means they are being generated or coming out of the same engine. Second stage is that recon. How do I actually find out information? Traditionally, we fire off multiple scans. We dump users' data. You get access into a network. You try and download the Active Directory. It's all effective. It's noisy. You have a lot of information. The person has to go through multiple levels of data and then decide what is the attack he's going to do on the organization. With AI, it becomes faster. You now have discovery agents that probe both passively and selectively. The difference is you are not going to have constant scanning, constant signatures of people or machines beaconing. It's going to monitor your internal traffic, enumerate systems using native commands, and prioritize the targets. So what that does is, You no longer require an individual to review the findings and then decide which is the best way to attack. The system is going to be actually looping through multiple attack paths. It will check, can I access here? No. Replan, redo it, replan, redo it. Similarly, exploitation. Normally when a malware comes in, it just gets executed on the machine. Max to max, it gets loaded into the memory, executed from the memory. There is no context checking, there is no real-time decision making. And the problem is, half of the time it gets caught by an EDR or an AV. So the number of malwares that are getting picked up is significantly high. The only way they can actually execute is bypass your antivirus or your endpoint detection control. Again, enter AI. It observes before it acts. So what we are seeing now is malwares that just do not execute. They first sit in the machine, look at what are the controls on the machine, what are the mechanisms that they have, what is the access restrictions they have, and then plans out how to execute the payload. And if it fails, it analyzes, it goes back to the Windows logs, it finds out what caused the malware not to execute, and then redoes and recompiles and re-executes. Let me give you an example. So this is from a Russia-based threat actor. This is one of the first known LLM attacks. It's called a lame hug. Right? So this was during the Russia-Ukraine war. There were multiple emails impersonating Ukrainian ministry officials. All of them received a zip file. Inside the zip file was just a Python controller. Now what happens was when the Python controller is executed, it calls back to a URL with prompts. And the URL then has an LLM which reads the data. It defines what is the payload to execute, passes it back to the machine, and then it gets executed. Which means you're not going to have massive payloads, but only relevant ones which will work on the environment. API communication, that was another capability that was there. So the malware was sending the prompts to Quen 2.5 Coda 32B instruction code, and it was being hosted in the Hugging Face model, which is a very famous public model for running LLMs, and command generation. Maybe the next screenshot will explain. So this is basically the dissection of the code. Not sure if I have a laser pointer here. Is it? No, I don't. So if you look at the right down, you see the LLM query X. What it does is, it first checks what is your administrative control. If you are a Windows system administrator, it tells the content, this is the command I want you to execute. So that parameter basically goes back into an LLM, which then tells it, this is the command you're going to execute. Once the malware receives that command, it executes it on the user machine, sends the result back. So what then happens is, you no longer have a historical archive of what command has the malware done. Even if you're analyzing in a sandbox, you will not be able to see what a malware can do, because the execution of the core engine sits somewhere else. Next one is persistence. Previously, how malwares used to achieve persistence, first one was using scheduled task. Scheduled task is Microsoft's own tool for whenever a program needs to rerun or execute again, it basically uses the scheduled task. Right? Yeah? Any other? Okay. Oh, got my pointer back. The next one is registry keys. The startup of a file, whenever Windows loads up, it goes to the registry key. Any program mentioned there executes. Startup folder implants, wherein when you start up a folder, there are some files or functions that get stored over there. Now, but the challenge with this, which is a traditional method of maintaining persistence, is an antivirus or an EDR or even an individual can clear it up. They might clear the temp folder, they might clear the startup, and then your persistence is gone. Again, so this is where AI comes in. So what AI does is it basically goes through your endpoint posture and then decides what's the best way to dynamically establish a persistence mechanism. Now, what that means is it's no longer restricted to what you have, but it also goes beyond to the applications that are installed. For example, using a Google Chrome extension to maintain persistence for a malware, using identity tokens to maintain privilegement persistence. And it also gives the malware the ability to fall back and re-establish. For example, somebody comes up, cleans up, removes all of these access, automatically the AI program picks it up, re-establish those. So it kind of enhances or ensures the person has a longer foothold. Now for these three, I'm not giving you examples because I will go through a major malware example which covers all of them together. Defense evasion. Now, half of the time what malwares do, I mean, if you've been to one of those tracks on the technical side, you'll see the guys breaking apart the malware, looking at the codes, saying this is what the malware can do, A, B, C, D. So most of the times what the attackers try to do is they obfuscate the payload. They try to make sure that the payload cannot be disassembled, removed, or relooked at. They try to rename binaries. They inject it into common process. For example, back in 2000, 2002, whenever you have a Microsoft Edge, or Internet Explorer, we used to call it AIA Explorer, you'll always see multiple AIA Explorer, half of them are viruses, if you go to a cafe. But again, those were traditional methodologies. In the more AI-driven version, what we see is self-writing. This is basically malware that can rewrite its own payloads. If it is flagged by an EDR or an AV, it then looks at what are the new evasion techniques, recompiles, and then redeploys. It looks at prompts. It basically prompts itself to test what is the execution paths and then try and redeploy them. Even in terms of communications, it is able to encode it differently, and it can even operate, autonomously. You don't even need to tell it how to send it. It might store in some open public forum and send the link back to the developer. Which then brings me to this example, c0c0n. Now, c0c0n was a malware which just came about and it impacts Linux. So what's special about this is, I know it looks really fancy. I'm going to simplify it, make it as easy as possible. Somebody found out that they could access a misconfigured Jupyter Lab repository. They gain access. They then deploy backdoors on multiple systems over there. And now using those backdoor systems, they deploy two images, Panda H14, Panda V14. Those are actually two images, but they are polyglot files. So polyglot files basically can function as two files. Simple example, if you look at your Office file, it's .docx. But you can also rename it to .zip, and you can unzip it and see what is inside. So these are all both JPG files. One of them has got a hidden code, which is a C language that can be compiled to launch a rootkit. The second one basically is a bash script, which is used for exploitation and installing a crypto miner. Now, where it gets interesting is, once this malware gets executed, it basically uses AI to look at what are the configurations, what are the system boots, and start setting up parameters in such a way the malware can self-replicate and maintain continuous persistence. It also does cron jobs, which is like scheduled tasks for Windows, to ensure that it gets relooped and relooped on. And the challenge is both the payloads are hosted as images, which makes it really difficult for EDRs and AVs to actually pick up. This has actually been a trend of one of the new generation attacks, where it's kind of difficult for the AV or the detection engines to pick it up because they do not leave back signatures. They kind of act autonomously. I mean, despite looking at different files, directory, how to hide, where to run the malware is also capable of manipulating the network, resetting how the network systems are set up, and then, like I said, act on objectives, deploy a crypto miner. And it just does not deploy any crypto miner. It supports about 18 cryptocurrencies. Based on the configuration of your hardware, it deploys the relevant cryptocurrency miner. So this has been one of the most, sophisticated malware that we have actually seen on Linux. The next one is something which everyone is concerned about, data exfiltration. Traditionally, data exfil was slow and blunt. You usually compress every data. You identify one staging location. You copy the data to a staging location. From there, you then exfil the data out. Now, the problem was if the data was really big, there's a high chance that the network guy might pick it up or your SOC might pick it up, which means big payloads, big risk. Now, when it came to AI, it actually found multiple ways of doing data exfiltration. It could identify valuable data, prioritize it. It could test multiple covert paths. So rather than just exfiltrating all the data, it could read the data, decide these things, PII, more important, set it out first. These things, PHI, set it out next. These things, system information, we don't need them. Do not set it out. Next thing is it could throttle traffic. You don't have to send the huge amount of data. When it is a computer working, it has patience. When it is a person working, we do not have patience. So it can actually throttle your entire traffic, take its own time and delay, send the traffic out. Which brings me to another example called SparkCat. Now, I talked about Windows, I talked about Linux. SparkCat is a malware targeting your Android and iOS. So what it does is simple. It screenshots, does an OCR, which was really a really good way of grabbing information from your mobile devices. And whatever data it was captured, it was then structured into a JSON format and then exfiltrated to an attacker's server. And how they did SparkCat was interesting. It was not one program. It was an extension that was bundled with multiple Android and iOS projects that were live. For example, UAE and Indonesia, they got a version of SparkCat in their food delivery app. So what that used to do is to go through your photo gallery, analyze all your photos, convert anything into text, sends the data back along with your mobile device IMEI number, so you can actually map it back to the person. There's another one which was basically searching for crypto wallet information, and it was specifically sending to one particular IP address, which allowed us to find out that it was related to Serbia. There's another one which is where, so the entire OCR module was basically identified to be based out of Google MLKit. So that is where we are actually seeing most of the AI agents working and uplifting on the different stages of cyber attacks. And agentic is basically what we are anticipating for the future. What we are expecting to see, and this has come out as a research project, is a malware which is autonomous. It is capable of making its own decision. It can adapt and evolve. No matter how you try to actually remove it from the system, it still comes back. It does not require a C2. It can build its own C2, and it collaborates with other malwares. So, for example, if it sees another malware using the similar protocols, it can actually share some of its information, and it also gives a low entry barrier. We are talking about somebody with zero programming experience running malwares of their choice. And what that does is it actually leads to data exfiltration time. It has gone down from 9 to 2 days. The mean time to exfiltrate is roughly about an hour. There's a time reduction in reconnaissance. It is also able to classify information, deploy multiple payloads. And I think before I conclude, one last piece which I need to touch upon is AI on crime, because it's a law enforcement conference as well. Some of the usages are which we have seen on the criminology side, is child sexual abuse materials. For example, IWF, they have observed around 3,500 new AI-generated abuse images over a span of 1 year. Disinformation operations, I think everybody knows about it, especially during elections, during campaigns. There is a massive flood of fake news on social media, frauds and scams. I did give you a couple of examples, and these are some of the samples. So the one on the left is basically the China deepfake hacker group, where they were charging $500 for any deepfake model of a face, and $2,000 for a full year support. On the one on the right is basically North Korea's deepfake attempts at South Korea. If you have time, you can read about gold pick hacks. This was basically a malware. I mean, that was researched by Group IB, which fakes as a fake banking app. It asks the user to come online in a video call to validate the user, takes the user's image, generates biometric fingerprints, starts publishing the data out. This is another example, pro-Russia campaign. This one took the Wall Street down for 10 minutes, where there was a fake image of explosion at Pentagon. The doppelganger campaign, Pakistan election AI use. Matryoshka is a really interesting one, which was basically to create a content explosion and fake news against Ukraine. So I think with that, I would like to conclude by saying that at this day, it's becoming increasingly difficult to spot what is AI generated, what is human generated. It becomes challenging to mitigate AI driven attacks, which is why we are now trying to look and focus on building more tools for defense using AI. Thank you.